So now back into cymatics, looking at the first octave again, you have A to G showing the cymatic formation of the patterns of each key. So what am I showing here above? What I'm showing are planets. These are planets looking through a Nikon P900. Although they are out of focus, what you're going to see here is astounding. So what we're looking at is Mars here, and what you can see is the ripples of the atmosphere, the water in the atmosphere. Did you know that air is a fluid? Although fluid is sometimes used as an alternative word for liquid, air is treated as a fluid in the field of fluid mechanics. Objects moving through air encounter forces and experience conditions similar to objects traveling through water. Now, on a side note here, I want you to go back to the mythology of water when we were talking about all our ancient cultures talking about the water all around us. And within what they were calling the dome is more water. Remember, there's 37.5 billion gallons of water here. There is water completely surrounding us and within us. Water is so important. So this is a great experiment of how water interacts in our atmosphere.
Most people do not realize that the air is not transparent. We will use transparent sheets for our example. Also, we will use lighting gels for the water and lower water line. This will simulate the horizon the way it is on Earth. Each sheet should represent several miles. The key people need to understand is that the horizon you see is not the exact horizon. If there was no air, no water, or anything else, the horizon would be lower on a perfectly flat plane. People misuse the word vanishing point and perspective, and here I will prove how it works. The first concept is air density. Have you ever driven on a foggy day? You can't see 2 feet in front of you sometimes. Air compounds. Every mile, there is more air to look through. This forms a gradient. When we put several sheets of clear plastic in front of the other, they form a wall that you cannot see through. The atmosphere is filled with oxygen, zinc, carbon, hydrogen, and many other chemicals that forms a wall of density. Let's watch the experiment in action. As you can see, the sun gets cut off from the bottom first. But that's not all. There is many things to discover in this experiment. First of all, you can see the light shrink around the sun as it sets. This is exactly what we see in real life. When the sun sets in our experiment, we see a color change, just like real sunsets. One major difference in our experiment is it's on a small scale and it's low budget. The advantage is you can do this yourself at home. In our experiment, we have lower atmosphere, middle atmosphere, and high atmosphere. Did you know that the air gets thinner as you get higher? This is because of buoyancy. You see things that are less dense separate from things of greater density. This is why clouds float. This is why helium balloons rise. This forms a vertical gradient and gives us a horizontal and vertical air gradient. In fact, the speed at how fast things fall depends entirely on buoyancy. If you drop an item in the water, it falls much slower than in low altitude air. If you fall from a high altitude, you fall faster. When you jump from air into water, you fall fast and then slow. Now we combine all three ideas, and you will get this. Right at the horizon there is a 10 to 20 mile high wall of air. The wall of air depends on weather. Remember, it's a vertical and horizontal gradient. Think of it like a diagonal wall or a ramp to heaven. On high humidity, the wall will be closer. On low humidity, the wall will be further, sometimes hundreds of miles. The air compounds.
So now that gives you an idea of when you see a full moon or a harvest moon coming up and the moon is like that big. And then it gets up into the sky and then it's like that big. But what you're looking through is that 20-mile vapor of water, and the water is magnifying it. Just like when you see a sunrise and a sunset, the sun tends to get bigger as it sets and as it rises because it's moving through that 20-mile vapor of dense water. So water is completely surrounding us. And remember, water carries information. And information can be imprinted through our emotions and our thoughts. So what we're projecting into the world, we are then encasing in the water all around us into the collective consciousness. And the water is then ingested by everyone around us. The important thing here is for you to hold a high vibrational frequency when you're drinking and you're eating food and you're talking to people, because what you're doing is you're influencing the water around you. So now we're going to talk about buoyancy and density. So now this video here might be a little bit strenuous on the mind because there's some math involved, but I really wanted to give you the foundation and the basis of buoyancy and density, because moving forward, when we get into the sciences of why things are the way they are today and where we're headed, I want you to have a good understanding of buoyancy and density.
The spectacle unfolding behind me here is a graphic demonstration of buoyant force. Amazingly, the buoyant force acting on a hot air balloon is able to lift a basket filled with passengers. This powerful force appears whenever an object is immersed in a fluid. Do you know what fluid this hot air balloon is immersed in? Remember that both liquids and gases are fluids. The fluid surrounding the balloon is air. Let's investigate the buoyant force in another fluid, water. This is a concrete block. This is a wood block, a softwood block, pine actually. I'm going to drop these two blocks into the water in the aquarium. One will sink, one will float. You probably have a prediction about what's going to happen. Let's find out. I suspect your prediction was correct, that the concrete block sinks. When I ask the question, why does the concrete block sink? The answer often is the concrete block is heavier than the wood block. We have to be careful with our vocabulary and understanding here. Consider a cruise ship. More buoyant force. This cruise ship behind me is in fact a huge hotel floating on the surface of the ocean. These huge ships can weigh over 50,000 tons. Despite this huge weight, cruise ships have no problem floating on the ocean. Whether an object sinks or floats is not determined by its weight, but by its density and the density of the fluid it is immersed in. Density is mass per unit volume. Let's calculate the density of our two blocks and the water they are immersed in. To calculate density, we divide the mass of an object by its volume. Our concrete block is a rectangular prism. You determine the volume of a rectangular prism by multiplying its length times its width times its height. The length of our concrete block is 7 centimeters. Its width is 5 centimeters, and its height is also 5 centimeters. 7 by 5 by 5 centimeters. Doing the multiplication, we find the volume is 175 cubic centimeters. Now we need to determine the mass of the block. Using a digital scale, we find the mass of our concrete block is 400 grams. Density equals mass divided by volume. Doing the division, we find the density of our concrete block is 2.3 grams per cubic centimeter. We will calculate the density of our wood block using the same method. Measure length, width, and height. Then multiply to determine the volume. This wood block has a volume of 388 cubic centimeters. The digital scale tells us this block has a mass of 161 grams. Inserting the numbers into the density formula, we determine that this wood block has a density of 0.4 grams per cubic centimeter. I rounded the results to 1 decimal place. Now to calculate the density of water. Let's determine a volume of water using a graduated cylinder. This graduated cylinder is calibrated in milliliters, the common volume unit for liquids. 1 milliliter is equal to 1 cubic centimeter. Because we will be measuring the mass of the water in the cylinder, we need to subtract the mass of the cylinder from the total mass of the water plus cylinder. A digital scale makes that easy to do. Sit the empty cylinder on the scale. The mass of the cylinder is displayed as 110 grams. Press tare, and the mass of the cylinder is subtracted. I can now remove the cylinder, fill it with water to the 250 milliliter mark, and set it back on the scale. We have 249 grams of water. Doing the math, we divide mass by volume, and rounding the answer to 1 decimal place, we determine the density of water to be 1 gram per cubic centimeter. That's interesting. 1 cubic centimeter of water has a mass of 1 gram. This is not a coincidence. If you research the history of the metric system, you will find that the first standard metric unit of mass, the gram, was defined as the mass of 1 cubic centimeter of water. Getting back to our investigation of density and buoyant force, this table shows the wood is less dense than water and that the concrete is more dense than water. The wood block floated while the concrete sunk. A conclusion from this data is that objects denser than water will sink in water, while objects less dense than water will float on water. This is true for other fluids, not just water. This means that the cruise ship, even though it is extremely heavy, is less dense than salt water. This is because a large portion of the volume of the cruise ship is air. Sometimes an object neither sinks nor floats. We say it has neutral buoyancy. Fish can adjust their density to maintain a state of neutral buoyancy. They do this by inflating an internal bladder with air. This organ changes the volume of the fish without changing its mass, allowing it to match its density to the water it is swimming in. Scuba divers use a similar method with an external bladder to control their buoyancy. Human beings are very close to having a neutral buoyancy. The makeup of each individual determines whether they sink or float. We have demonstrated that density determines whether an object will sink or float, but we have not explained where the buoyant force comes from. When an object is placed in a fluid, it displaces or pushes out of the way some of the fluid. This displaced fluid pushes back on the object. This is buoyant force. All objects in a fluid experience buoyant force. Even the concrete block on the bottom of the aquarium is experiencing a buoyant force, but the force is not strong enough to lift the block. The Greek philosopher and scientist Archimedes is credited with figuring this out. The science behind buoyant force is known as Archimedes' principle. This principle states, the buoyant force on a submerged object is equal to the weight of the fluid that is displaced by the object. This means that the denser a floating object is, the more water it will displace. An object with a density of 0.5 grams per cubic centimeter will float only partly submerged, while an object with a density of 0.9 grams per cubic centimeter will float almost completely submerged. Another interesting thing about buoyant force is that gravity plays a role. You may know that pressure in water increases as you dive deeper in a lake. Gravity creates this pressure gradient, and it is an essential part of buoyant force. It is not possible to create a buoyant force without gravity. Let's take another look at hot air balloons. We know that in order to float, a hot air balloon, complete with its passengers, must be less dense than air. Air has a density of only 1/1000th of a gram per cubic centimeter. Here is how the balloon attains such a low density. First of all, the balloon is huge. It has an incredible volume, typically 3,000 cubic meters, filled with air. The challenge is to reduce the mass of the air in the balloon. That is where the heat comes in. When air is heated, the air molecules pick up energy, increasing air pressure in the balloon. The balloon has an opening at the bottom. This allows pressurized air to escape, reducing the mass of air in the balloon. When enough air has escaped, the huge volume of the balloon, combined with its reduced mass, lowers the balloon's density below the density of the surrounding air, creating positive buoyancy. The balloon, with its passengers, floats into the atmosphere. For more science videos and projects, visit our website, hylaroad.com.
All right, so I know that was kind of brain intensive. There's a lot of math going on there. But like I said, it's going to help you as we progress further into the understanding of who and what we are. The moon. How does the moon affect us? Right? So if you look at astrology, astrology talks about how the moon is our internal selves. The sun is our external selves. The moon is our internal selves. It's our emotional body. Have you ever heard of the statement, a lunatic? A lunatic is a lunar. Lunar is moon. A lunatic. When the full moon comes out, they say all the crazies come out. Hospital visits go up. Police calls go up. All this stuff happens because people's emotions are peaked, right? So when the moon is at full, it's at full capacity, pulling on the motions of the water within the atmosphere and within our bodies. We're made up of between 100 to 50% water, depending on your age. And the emotions are being pulled on by the moon, just like it pulls on the oceans. So understanding this, we can use the moon to help assist us in manifesting what it is we desire. So now let me give you a little tip on how to utilize the moon's energy. So there's multiple phases to the moon, right? You have the new moon, the first quarter, the full moon, the third quarter, and then back to the new moon. When it comes to the new moon, this is where you can plant your seed ideas, things that you want to bring into your life, right? Because we're going to the full moon. And then once we get to the full moon, we start thinking about things we want to get rid of because the moon is waning down, okay? Very, very small, simple trick you can use to gain the energies of the moon and bring it into your life. So now let's talk about healing. How can we utilize water to heal ourselves? Because now we know that we can change the molecular structure of the water by simply holding the water, right? Remember the imprints? If you touch water, it imprints your energy on there. Well, when you draw your positive intentions into the water, you change the molecular structure. So when you do your meditations, hold the water in your hand and give it vibrational frequencies of love and compassion. And imagine what it is that you want to experience. So if it's a healing you want to experience, hold the water and see yourself as healed and project high frequency vibrational words and tones into the water and then drink it. And it'll help assist you in moving into the next phase of health, wealth, and prosperity. And with that, I thank you for joining me for lesson 2, and I'll see you at lesson 3.